this one up here, I wouldn't change this so it's all meters. I would change it all so it's all centimeters. Over here, I would change it all to inches. This one I would change all to minutes, like top and bottom. This one I would change to quarts. Okay. So in order to do this, since I know centimeters is smaller, that means I need to change this to centimeters. Do you guys know how many centimeters are in a meter? 100. So there's 100 centimeters in 1 meter. So since I have 4 of those meters, that means I need 400 centimeters. All right, the whole point now is because when you reduce ratios, you want no units there. The only way you can cancel out units is if they are identical. So they just go away. So I'm just left with the numbers 12 and 400, which I need to be able to reduce that fraction. You guys know what it reduces to?
By 2. 12?
Well, you can do it by 2. So if I 12 divided by 2 is 6, yes?
Yeah.
And that's 200, but I can still reduce that further.
By 2.
And that becomes what?
3 and 100.
And that'd be it.
Divide 100 by 3.
Okay? You could have just divided by 4.
No, this was much more fun.
Whatever, I don't care. As long as you get it done to the correct thing, that's fine. Okay, so again, on this one, I would, inches are the smaller unit, so I would take the feet and change it to inches. It's not a necessary thing, it's just a matter of, if I know how many inches are in a foot, I just got to take that number and multiply it by the 6. So that'd be 72. All right, the units are the same, they cross out. What's 72 divided by 18?
24.
What? 6? 24, think, come on.
7.
We should get a calculator out and actually
No,
check
just
it.
do it by 4. I have a calculator that says 4.
4.
It's not
4.
Guys, it's 4.
And that's fine. You don't need to write it over 1. It doesn't matter. All right, down to this one. This one usually. Do you guys know how many quarts are in a gallon?
No clue.
4.
16. 4.
Okay. All right, so 4 quarts a gallon. So that means on the top there, I'm going to have 20. 4. What's 20 divided by 4?
4 and 5.
405, yeah. That's a number I like. All right, how many minutes are in an hour?
60.
So what's 60 times 2?
120. 60 times what?
Minutes. What's 25 over 120 reduced to?
I don't know.
What would you probably divide both of them by? 5. There it is.
I bet it's 20.
So that's 5. What's 120 divided by 5? Quick.
110.
I don't know.
110? No.
It's 24.
What?
24.
Yeah, he's rushing me.
Like, do it.
Cross multiply. Okay? So, if you've done these before and they said solve for x, I would hope you would cross multiply. And again, cross multiplying is just you're taking the means and extremes and multiplying them together. Basically taking this x and moving it over there so it's 12x. And this entire thing and putting it over there. If you've got something other than one element there, like there's 2 here because there's x and a 6, make sure both get multiplied by it. Like you don't forget to distribute that through. What's 8 times 6?
48.
It's 12 minus 8.
12.
So x is
12.
So same thing here, right? This would still be a proportion because I've got a ratio here. Gosh, ratio there. So when I do my cross multiplying, again, do not do this because that would absolutely be the wrong thing to do. Make sure you put the parentheses around it. What's 7 times 6?
56.
No.
49.
7 times 7 is 49. It's going to be less than that. 5 times 4.
20.
20.
What's 5? So I'm going to subtract that with 6 minus 5.
It's 1. 82.
82 or 62.
62.
One or the other. Geometric mean. I'm bringing up now. We're not going to actually apply this until we get to the next chapter with the right triangles. For you guys right now, all you need to know is you have to be able to find what the geometric mean is between two numbers. This will always be, I'll give you two numbers and I'll say what's the geometric mean. Okay? That's what you do. If I give you two numbers, it's basically you multiply them and you take the square root of it. Because the setup is always going to be that proportion. The two numbers I give you, like if I told you 4 and 10 or 4 and 20 or whatever, you would put those numbers in the position of A and B there. The X is just considered the geometric mean, and it gets repeated in the proportion. So when you do your cross multiplying, you'll have X times X, which is X squared. And to get rid of a squared, you'd have to do a square root of it. So if I said, here, like this would be a basic problem you would do now. Like I wouldn't do anything other than this right now. So I'd say, look, I got you two numbers. You just tell me the geometric mean, which, again, do not get this confused with this one, arithmetic mean. This is the, like, average that you guys are all familiar with, which would be like 10 plus 3 divided by 2. That's a different mean, okay? So that's not what it's asking you to do. The geometric mean, again, is you do... the geometric mean equals the square root of those multiplied together. So you can leave it that way. If these things can be simplified and you remember how to simplify them right now, you can. If you want to make this a decimal, which is probably like, I don't know, 5.4 or something like that, that's fine. Like if you actually go in there. You run into a problem that says, are the shapes similar? This right here, that's like the work portion. Like that's technically what you're doing. You'll have numbers and stuff to work with. The first thing that I would suggest you do, if you have your two shapes, wherever they're at, these are marked nicely. Some are not going to be. The first thing I would do though is I would check the angles. Because if you cannot match up all the pairs of angles as being congruent, there's no way they're similar. That means you don't have to do anything with ratios, you don't have to reduce any numbers, nothing like that. So I would check the angles first. So like if two of these were probably missing, you would just say they're not similar. Okay? So I would say check the angles first, just because that's the quickest thing that you can check. Like you can usually do that by looking at what's marked off. Like there isn't really much else you have to do there. After you do this part, then you're going to come down here, and this part right here is you're checking to see if all the sides come down to the same ratio. So you'll have numbers in there, like you'll have 2 and 3 here, and they might have 4 and 6 there, you know, whatever. But what you would do is you would put in the actual numbers for each side, and then once you put the numbers in, you're going to reduce them. And as long as each of these fractions reduce to the same thing, then they're called in proportion. Now again, when you're matching these up, by definition it says you're matching up the corresponding sides. But the corresponding sides, when you match them up, are going to be in order as you pick the two smallest sides, those correspond. The two biggest sides are going to correspond. The two middle sides are going to correspond, so on. So you don't have to necessarily worry about the way it's going to be ordered or the way it's sitting. All you need to do is go, that's the smallest side, so's that, those correspond. Okay? And go like, well, that looks like it's the biggest side, that looks like it's the biggest side. Those are the two numbers I'm going to put together. That will make your life much easier when you're trying to match these up. Okay, so just make sure what you guys will actually do is you'll actually plug numbers in, reduce the fraction, as long as they all come down to the exact same fraction, then it would be considered similar. Yeah.
What's the symbol between the...
I'm getting there.
Is that congruent or is it...
This is the symbol for similar. Okay? Because similar means they're the same shape but not the same size, so you're taking like the equal portion away from the congruency sign. You just left a little squiggle thing that's on top. All right, this right here, this as a whole, this statement is called the similarity statement. very much the same in terms of working as what we did with congruency statements, where if I look at the statement, I can look at the third letter and say angle C corresponds to angle I. Angle D corresponds to J, A to G, so on. And I could also use this statement just like with congruency statements to match up corresponding sides. Like I know side BC and side HI have to correspond because they're in the same position. So whenever we did this up with congruency triangles, like the congruent triangles, this is the same kind of idea. When I write out a similarity statement, which is just saying what things are similar, I have to organize this so that the corresponding letters sit in the same spot. So whatever corresponds to A needs to be first there. B, so on, so on, so on. Okay? This statement over here, this thing, as it looks right here without the numbers, where they're telling you which sides are in ratio with each other, so the corresponding sides, this thing is called a statement of proportionality. Okay? If it's ever asked of you to write a statement of proportionality, it means you write a large proportion, it's like an extended proportion, with the letters of the sides, not the numbers. Plugging in the numbers here would be the work you do to tell if the shapes are similar. So if it says statement of proportionality, you write exactly as it looks over there. Okay? That's probably not going to be asked that much. This you'll have to write, definitely. And being able to check the angles and actually plug the numbers in there are also going to be expected. The angles. Are the angles all congruent to each other? Like if I paired them up, they're all the same? Okay. The other thing would be, once I checked all the angles, which that's fine, then I have to match up my sides, but when I do, I got to put them into like a ratio, so a fraction. And I always want to do the smallest side of this shape compared to the smallest side here. The biggest side here compared to the biggest side there. So like what in this one that's on the left, what's the smallest side? 6. What's the smallest side there?
4.
So if I saw that, I would write out 6 over 4. What's the biggest side here?
10.
It's the biggest side over there.
8.
Okay. Reduce them.
3 over 2.
Is that reduced to 3 over 2?
Yep, 5
What's that
over
reduced
4.
to? Are those equal? Are those equal?
No.
Not similar.
Really?
Okay? So look, with this one, again, what's the first thing I say to check?
Angles.
All the angles. Do I know absolutely anything about the angles?
Yes. I mean, you can tell they're congruent because you can do the thing.
Is anything marked congruent from one shape to the other? No. Unless, guys, unless you got a way to link like this angle here to this one over here, then you just say no. I know within this shape, like those two angles are equal and so are those because they're parallelograms, but I don't know anything between the two shapes.
Yeah.
You have to know a link between one shape to the other, not just something that's going on within the actual shape. Anytime you run into similarity, I'm going to repeat it. When they give you this, remember that little symbol means they're similar. That means if I need to find a side length, like if I need to find x, you're going to set a proportion up. If I need to find this side, proportion. If I'm dealing with angles, then I can set things equal to each other. You should never set things equal to each other if you're dealing with similarity. So as soon as you see the word similar or you see that little squiggle for the symbol, set a proportion up. Okay? I'll tell you, there's going to be like 5 or 6 people I forget that on the test, and they're going to set things all equal to each other. All right, which is wrong. Okay? It just kind of happens. People just, you lose your mind on tests sometimes. But just remember, if you were to set like, for instance, this side corresponds to this one, right? It looks like it's all in the same spot, correct? Okay, if you were to set those equal to each other, that would be saying that this shape and this shape are exactly the same. They're not exactly the same. I would hope you can look at it, and these are going to be kind of drawn to scale, so you can say that's smaller than that. So that means that they're similar, which was told to you. So in order for me to find like x, I need to set a ratio up. When you put your variable in there, usually I put it in the numerator. Just, I don't know. It looks nicer. It's usually easier to deal with. Whatever you put beneath it needs to be the side that corresponds to it. So again, like I said, this side and this side correspond. So I threw a 10 there. All right, for me to actually do this proportion, I need on the other side, I need a ratio, a fraction that has two numbers in it. I don't want any other variables in this one. So that means like this side I ignore for right now, that side I ignore right now. Which also means that the ones that correspond to those sides, like y and 16 correspond, so I'm ignoring that one. W and 25 are gone. That only leaves me with two numbers, 15 and 12. So when I do my proportion over here, 15 and 12 need to go in there. I just got to make sure I put them in the correct positions. So out of 15 or 12, which one do you think I'm going to put on the top?
12.
Which one?
12.
15, why?
Because you got to match it up with X.
It's on the same side as X. X is on top. I'm going to want the one that's on the same or on the same shape to be there. Boom. So I got 12x equals 150, right? When I cross multiply. What's 150 divided by 12?
Something.
13.
It is something, but I don't know. Is it?
14. It's 14. Wait, what?
Low pressure? Oh my god.
You did a horrible job. One at 12.5.
12.5.
I missed the best.
Okay. And then like you would just repeat the process for all the other variables. So this one has multiple. So if like I wanted to find y next. If I wanted to find y again, I would say, okay, I'm looking for y. I know this thing is similar, so I have to do a ratio here. The side that corresponds to y is right there, so those go in fraction. The other side, I can still use, I could technically, once I know that's 12.5, I could also use that number now. But since I've already got 15 and 12 set up over there, I might as well just repeat them. Yeah. What's 16 times 15?
240.
And what's 12 divided by, or 240 divided by 12?
20.
20?